Hello, we're Team Peggers participating in Rice's BME Hackathon. For background about who we are all Duke freshmen in the School of Engineering studying biomedical engineering and mechanical engineering respectively. For our design challenge, we're tasked with humidification for CPAP machines. So bubble CPAP, continuous positive airway passage therapy, is usually used for respiratory illnesses in premature babies and in young children, and involves blending oxygen at heat and humidity that is purified to the baby's lungs.
So now we're going to go over a problem statement. So we have a problem statement right here, and we really want to emphasize the fact that we're creating this device for low resource communities. And now before we get into actually what we did do a little bit of project planning, even though this was a 3-day event. So we first created a Gantt chart to do sort of a plan for what we're going to do for the next few days. And then for documentation, we used a Trello board to kind of record everything that we did step by step. And finally, if engineering is really important that you communicate, so we used group chats and Slack for group communication. Now here is our Gantt chart. We created this on the first day, and we didn't exactly follow it straight to the letter for every hour. It's more of a broader idea of what we're going to do for the next 3 days. Now, next, we started with research and brainstorming. So what we did is we looked at our problem statement and we digested it into 4 design criteria that we sort of wanted to look at. And then we quantified with accepted values. And ideally, we would have followed testing procedures. And now we also decomposed our problem 2 into manageable design components. So as you can see here, we have our 5 top components that we wanted to focus on and would have been instrumental in our brainstorming process. So we have those 5 components to our left in a sort of list, and we have ideas for each component. And then to our right, we have physical drawings of how we would fit these different components together for a final solution.
When it comes to selecting solutions, we used a bit of an informal process. Instead of using decision scoring matrices like Pew or screening, we ended up in the middle of our research just trying to think of which solutions would be practical with the time constraints and which filled our design criteria. The result is for our temperature design criteria, or for our temperature decomposition, we had a DHT11 sensor, same as the humidity sensor, plus a 5-volt heating pad to connect to an Arduino. For the humidity, we have the same sensor, DHT11, with an impeller or an atomizer that comes from an old humidifier we used. For sanitation, we tried to use a UV light to help purify the water. And for the user interface, which is a basic screen, and the airway tube, those are represented through figure 6 and figure 4 before in the slideshow.
All right, now onto the prototyping process and how we built our prototype. Here's a general pathway of our process. We first began with building the shell for the inline tube, and then we moved on to deconstructing our old humidifier to sort of salvage the humidifying parts. And finally, we put this all together with an Arduino to see how the sensor works with the potentiometers that we use to enable user modification of the parameters and so on. We can watch this video. This is in our folder that is shared. In the interest of time, we're not going to play it here. And on to our final design. Given the time constraints, we could not construct this full design, but we have CAD models of everything. Here's a picture of our plan for the electronics box. It's a simple 16:2 LCD that displays the target temperature and the current temperature of the air passing through and the humidity that is passing through the tube that we designed. And you can see there are 2 knobs to adjust the parameters. Here's a picture of the full assembly. We have the box, electronics box in the lower left corner. The white tube is where the UV light is. The tube sort of expands so that airflow slows and it has more time to be sanitized by the UV light. We also have the sensor is later downstream of where the sanitation is. The water bottle is cheap, so we use that to hold the water that we use to humidify in the light blue box. And the sensor is later in the air outflow, so we can check how our devices are doing.
For future work and what we learned and what we will do, for our testing for sanitation, we were going to have a steam purity test to test how pure water was, but clearly with interest in time and the resources we had access to, we could not do that. Also, for the humidifier we used for the atomizer, it was not functional with our Arduino, so it is something in the future we'll try to use. And in the future, because we use an Arduino, we will try to use lower profile electronics that could hopefully work with an actual patient. For what we learned, this project was very helpful for teaching us how to complete a difficult task under the time limits of a hackathon like this. It also taught us how bubble CPAP machines function and how to assemble one, and why these CPAPs are not currently accessible, and hopefully increase their access in low resource areas where they're needed most.